I want you to think about this. If you want an affordable way to test some mechanical system, you can use Lego technique, given that the system is simple enough. If you want to test an electrical system, you could use some online simulation, or even just buy the electrical components. The basic ones are not too expensive. But what if you wanted to test some hydraulic system? Anyways, I haven't found any cheap solution for doing tests in real life. Yes, you can do it on paper, but only for really simple circuits. Also, it would be cool to see the system in work. So I will make my own modular system for testing hydraulic circuits. The Onshape files are in the description, so you can make it yourself. You will, however, need access to a 3D printer. The other material includes 5/16" silicone tube, O-rings, and Gorilla Glue. The tube and the glue you can find at a hardware store, but for the O-rings, I recommend Amazon. The filament I use is PLA, which I guess is fine as long as the filament material you use is watertight. Okay, so the first thing I wanted to make was the fittings to connect the tubes with the various valves and other components. The fittings need to be watertight and also easy to connect and remove. The first design I made was the ribbed fitting. The idea here is that you slide the silicone tube in this side of the valve, and then you pull on this ring to firmly lock the tube in place. It probably would have worked with a more ductile material, but the PLA is quite brittle, and it broke almost immediately when I tested it. So my next design was to screw the tube and valve together. This was also a good time to figure out the gap between the inner and outer thread. Because you see, if you simply make the inner and outer threads juxtaposed in the CAD file, the plastic expands a bit when it prints, and then the two parts won't fit together. So, especially since the PLA is really hard, you can't squeeze it. The gap which worked for me was 0.2 millimeters in the end. So here we have the thread design, quite straightforward. Unfortunately though, it started leaking because of little imperfections and also the 0.2 millimeter gap. So I got O-rings for the next design, the thread seal. These O-rings were 21 millimeter outer diameter and 1.9 millimeter thickness. This design worked, but there was no grip to remove the inner fitting. The next design, Thread Seal V2, added some ridges to easily screw together the parts. At that point, I was like, okay, great, time to make some components. There was a problem though. When you screw in the tube, the whole tube twists, which is especially a problem if you have loops in the circuit. The solution for this is just to have it so that the fitting either doesn't turn or at least doesn't make the whole tube twist. The next design was the quick seal. This one has no threads. Again, like the ribbed fitting, it would have probably worked with a deeper groove and more flexible material, but I didn't want the PLA to break, so I made the grooves very shallow, and that just made it that it felt loose and flimsy. Now we arrive to the final design, the quick coupling fitting. This is like a cheap version of the real fancy metal quick coupling mechanisms. So I got smaller O-rings first of all. On Amazon there are deals of like 100 O-rings for $10. The new O-rings are 3/8 of an inch outer diameter and 1/16 of an inch thickness. There are three parts to this design. The first is the inner part, which is glued onto the silicone tube. Then the outer part is from the valve or the component, so you can just slide these two together and it's watertight, but it can easily get unplugged. So then the third part, the ring, can screw onto the outer part without twisting the tube, and now it's firmly sealed.